Hi, Year 12. Welcome to part 2 of these videos about the photoelectric effect. We're going to look at the structure of metals and how the electrons are behaving inside a metal. So this is important because the photoelectric effect involves shining light onto a metal surface and electrons being emitted from that surface. So if we're going to understand what's happening in the photoelectric effect, we need to understand what the electrons are doing inside the metal. So you'll hopefully remember or know from chemistry that inside a metal we've got atoms that are metallically bonded. So we've got metallic bonding, and what that means is that the metal atoms have become positive ions, and that's because the valence electrons, so the electrons in the outermost shell, have become delocalized. So we've got delocalized electrons, and those electrons are moving about in between the positive metal ions in the lattice, in the crystal. So in the photoelectric effect, it's these delocalized electrons, delocalized valence electrons, that are emitted when the light hits the surface. So what we need to understand about these electrons is that they've got a different range of energies. If we look at, let's draw a graph. So we draw a graph of energy. So this isn't really a graph as such, so it's just at one scale. So we're drawing energy increasing, and we can mark on to this energy scale the energy that different electrons have in a metal. So if we start down here, this might be the energy level that the electrons in the innermost shell of the metal atom have. And then as we go up, we would get different energy levels. Okay, I'm not drawing this in any way accurately, but within the atom, the electrons have well-defined energy levels. Okay. When we get to the valence electrons, so these are the electrons that were in the outermost shell of the atom, so they're at the highest energy level. Once those electrons have become delocalized, they can have a range of energies. So instead of a single line now, we're going to kind of draw a band of energies. Okay, so the delocalized electrons could have any value of energy within this band. We could also mark on here the amount of energy that a free electron would have. So an electron that has escaped totally from the structure of the metal, and we should specify that that's a free electron with a kinetic energy, let's call that EK, of 0. So this is an electron that has escaped from the structure of the metal, but it's got no kinetic energy. Okay. Let's just label that. This is the range of energies, the energy range of delocalized electrons. So we're going to define on this graph an important quantity that is going to come up again in the photoelectric effect, and that's something called the work function. So the work function is that amount of energy there, and we use the symbol phi. The work function is the amount of energy that is needed to free the most energetic delocalized electron. So the most energetic electron in the metal would be another way of saying it. So it's the electron that has this amount of energy here, right at the top of the range of different energies that the delocalized electrons have. And in order to make that electron free, we've got to get it up to here. So this amount of energy is called the work function. So it's the energy required to free the most energetic electron from the metal. Okay, so this quantity is going to be really important when we start looking at the equations, the formula that describes the results from the photoelectric effect experiment.